Hello students, I hope you're all doing well. Welcome to another video by QuickStudy. In this video, we will cover the topic of electron configuration and the periodic table. So let us begin. In atoms, electrons occupy and orbit the nucleus in shells called electron shells or energy levels. We can represent the electronic structure of atoms using energy shell diagrams. The way in which an atom's electrons are arranged is called the electronic configuration of the atom. For example, sodium has 11 electrons in each atom. The diagram below shows the electronic configuration of sodium atom. Each shell has a different amount of energy associated with it. The further away the shell is from the nucleus, the more energy that shell has. The way in which an atom's electrons are arranged is called its electronic configuration. Electrons first occupy the shell closest to it, which can hold up to 2 electrons. When this shell is full, the additional electrons are then filled in the next shells. The second and third shell each can hold up to a maximum of 8 electrons, while the fourth shell can hold up to 18 electrons. The outermost shell of an atom is called a valence shell. An atom is much more stable if they can completely fill this shell with electrons. In most atoms, however, the outermost shell is not full. Therefore, these atoms react with other atoms in order to achieve a full outer shell electrons, which would make them more stable. In some cases, atoms lose electrons to entirely empty the shell so that the next shell becomes a full outer shell electrons, which will make them more stable. The electronic configuration can also be written out rather than drawn. For example, the electronic configuration of sodium is 2, 8, 1. The numbers represent how many electrons a shell has, while the full stop separates each shell. The electronic configuration of an element can be worked out from its atomic number, Z. For example, the atomic number of chlorine is 17. This means chlorine atoms have 17 protons as well as 17 electrons. Therefore, the first shell of chlorine atoms contains 2 electrons, while the second shell contains 8 electrons. Therefore, the third shell contains 7 electrons. Thus, the electronic configuration of a chlorine atom is 2, 8, and 7. When we draw a diagram of an atom, we usually represent the shells using circles, and we use dots or crosses to represent the electrons. The electronic configuration of the first 10 elements are shown below. There is a clear relationship between the electronic configuration and how the periodic table is arranged. Elements in the same group of the periodic table have the same number of electrons in the outermost shell. For example, calcium and magnesium are both in group 2, for which we can understand that both elements have 2 electrons in their outermost shell. The number of electrons in the outermost shell is the same as the group number for groups 1 to 7. Since lithium is in group 1, we can understand that lithium has 1 electron in its outermost shell. The period number gives the number of occupied shell or the highest occupied shell. For example, calcium, which has an electronic configuration of 2, 8, 8, 2, is in period 4, and thus 4 shells are occupied. Similarly, iodine is in group 5 and thus has 5 electron shells occupied. Groups in the periodic table contain elements with similar chemical properties, that is, they react in the same way. For example, all the elements in group 1 react vigorously with water to form hydrogen and hydroxide with similar formula. For example, lithium hydroxide with the formula LiOH, sodium hydroxide with the formula NaOH, and potassium hydroxide with the formula KOH. All the elements in group 7 react with hydrogen to form compounds with similar formulae as well. For example, hydrogen fluoride with the formula HF, hydrogen chloride with the formula HCl, and hydrogen bromide with the formula HBr. All the elements in group 2 form chlorides with similar chemical formulae as well. For example, MgCl2, CaCO2, etc. But the question is, why do elements in the same group have similar chemical properties? Well, the reactions depend on how many electrons there are in the elements in the outermost shell. These are the electrons which normally get involved in chemical reactions when elements bond with each other. Elements in the same group, apart from helium in group 0, have the same number of electrons in the outermost shell. Therefore, they react in similar ways in a chemical reaction. Now, let us move on to the 8th group of the periodic table, the noble gases. The groups or elements are called noble gases because they're almost completely unreacted. In fact, the 2 at the top of the group, neon and helium, don't react with anything at all. The elements in group 0 have 8 electrons in their outermost shell apart from helium, which has 2 electrons. The lack of reactivity of elements in this group is because the outer shell is completely full. Therefore, there is no tendency to lose, gain, or share electrons in a chemical reaction. With this, we have come towards the end of this video. Now, let us have a quick recap of what we learned so far. We learned about electronic configuration and how to show electronic configuration using electron shell diagrams, as well as how to show electronic configuration without using diagrams in written form. We also learned how electrons occupy the shells in an atom, and finally, we also learned how the electronic configuration of elements is linked with how the elements are arranged in the periodic table. Thank you for watching this video. If you like this video, do consider subscribing to our channel because we post regularly on different topics and subjects covering the GCSE syllabus to help you ace your exams. For more information on our one-on-one online tutoring services, do visit our website www.quickstudy.uk. Thank you.